Okay, today we're going to look at lessons 12 and 13 merged together. So you should have the notes from the outbox. I picked a couple questions from each of the lessons and put them all together. Okay? So this past weekend, my husband opened our pool. But there was a leak, so we had to drain the whole pool and pretty much start from scratch so that he could change the liner. So when he had to change the liner in our pool, he had to take off the rim around the edge of the pool. And what would that be considered? The edge around the pool, that rim. That's the perimeter. First, he had to peel off the nasty cover. So the nasty cover on the pool is considered the area. So we pulled off the cover, which is the area. He took off the rim, put in the new liner, put the rim back on, and then we had to fill the pool back up with water. So filling the pool with water is volume. Exactly. So volume. And that's what we're going to look at today. You're all familiar with volume from elementary school. We did volume earlier in the school year, but today we're going to have a new look on volume. We're going to find a different way and some relationships with volume. Okay? And in the process, you're going to help me pack. Okay. Here we have 3 different boxes. Okay, as you all know, all the 6th grade teachers have to move to that hallway. All the 7th grade teachers are moving to this hallway. So all the teachers are busy packing. So all the teachers are fighting over boxes. That's why I asked you gentlemen not to sit there, because I have a couple of boxes on that back table. I want to figure out which box has the biggest volume so I can put the most stuff in it. But sometimes I might want a smaller box because if it's like heavy textbooks, I don't want to kill the custodians and break their backs trying to move these heavy boxes. So I have to look at the different shape boxes and the volume of the different boxes. So that's what we're going to do today. So we're used to finding volume, length times width times height. So let's do that. So let's write our 3 expressions for our 3 rectangular prisms. So volume equals length times width times height. Volume equals 15 times 1.5 times 3. Volume equals 15 times 1.5 times 6. Volume equals 15 times 1.5 times 9. Let's take a look at these 3 numerical expressions. Does anybody see anything in common? Or something that looks familiar? Wait a minute. I've seen something here before. All right, they all have this in common. The length is 15 and the width is 1.5. The length is 15, the width is 1.5. The length is 15, the width is 1.5. So they all have length times width in common. Wait a minute. Length times width? What? What's length times width? Area. Length times width is what we use to find the area. So let's see if they all have that in common. Let's fill in the next part. So they all have in common. That's what? 15 times 1.5 is the area of what? Area of the base of the box. So if I were to look at just the bottom of the box, that's the area of the base. So here, 15 times 1.5. Remember that our capital letters always represent a formula. So we know that capital A equals area, length times width. Capital V equals, whoops, I just spelled volume wrong. It's volume, which is length times width times height. Capital B is the area of the base. So we're used to our parallelograms as being base times height. But that's why some variables are lowercase and some variables are capitals. A lowercase b just represents the measurement of a base, like on a parallelogram. That's supposed to be a parallelogram. So a lowercase b would represent the area. I'm sorry, the lowercase b is the distance, the measurement of just the base. But a capital B represents the whole area of the base of the rectangular prisms. So they all have the same as the base. So instead of doing it over and over and over again, let's just find the area of the base. So what is the area of that base? What is 15 times 1.5? Well, no, multiply it. What is 15 times 1.5? So 15 times 1.5, 15 times 3 over 2. So that's 45 over 2. So it's 22.5. So I know that the volume of the first one is 22.5 times 3. The volume of the second one is 22.5 times 6. The volume is 22.5 times 9. All of those rectangular prisms happen to have the same length and width of their bases. So all of their bases have the same area, they just have different heights. I'm going to pause the recording so I could show you an example. So now, instead of saying length times width times height, can anybody think of a new formula for volume? Instead of saying length times width, what can I replace that with? What letter represents the area of the base of that rectangular prism? So what letter did we say can represent that? What kind of B? So that is another formula for volume. Take the area of the base, multiply it by the height. That works for every single three-dimensional figure. As long as you can find the area of the base, then just multiply it by the height and you have the volume. So now let's use our new formula to find the volume of each rectangular prism. So volume equals base times height. I already know that my base is 22.5 because we solved that on the other page. Remember, when we're multiplying fractions, we have to change them to mixed numbers. I'm just going to jump down here and skip that because I'm running out of room. So that becomes 45 over 2 times 3 over 1. 45 over 2 times 6 over 1. 45 over 2 times 9 over 1. Unfortunately, I can't cross-reduce this one. So 45 times 3 is 90. 135 over 2. How do I label volume? Cubed. Volume is always labeled inches cubed. This one I can cross-reduce if I want. 2 divided by 2 is 1. 6 divided by 2 is 3. 45 times 3 is... This one I can't cross-reduce. side. I just fixed the multiplication on the last one. So now we have our 3 sets of volumes. But let's pause a minute and look at the relationship between these 3 rectangular prisms. What do you notice about this volume to that volume? How could we get from 67.5 to 135? You sure? Go ahead. Multiply by 2. So this area is, this volume is doubled, and what do we notice about the heights? Doubled. So if I multiply the height by 2, I multiply the volume by 2. What about from here to here? What did I do to the height? Times it by, and what do we notice here? The volume is multiplied by 3. So because they all have the same area of the base, if I double the height, I double the volume. If I triple the height, I triple the volume. As long as I know the area of the base and then the height, I can find the volume. Any questions on where any of these numbers came from? Okay, let's take a look at the next example. Come on, there we go. On your notes, the height did not print. I don't know why it's on my screen. It didn't print. So the height is 5/3 feet. So now can I use length times width times height to find the area of this rectangular prism? No, I don't know the length or the width. But I do know the area of the base. So volume equals capital B times H. Volume equals 13/2 times 5/3. So now go ahead and solve. So 13 times 5 is? So 6 goes into 60 10 times with 5 left over. And now it's feet cubed because it's volume. Okay? This is the exit ticket, but I added it to our notes. So I wanted to have another practice problem. A new company wants to mail out samples of its hair products. The company has a sample box that is a rectangular prism with a rectangular base with an area of 23.5 inches squared. The height of the prism is 1 1/4 inches. Determine the volume of the sample box. So the base has an area of 23 1/3, and we know the height. So let's find the volume. Volume is base times area of the base times height. So the area of the base is 23 1/3. The height is 1 1/4. I still notice a lot of people trying to find common denominators. You only need common denominators for addition and subtraction. You do not need common denominators for multiplication. But we do have to change them to improper fractions. So 3 times 23 is 69 plus 1 is 70/3. And that is 5/4. Whoops. Can I cross reduce? Are you sure? Look at it again. Yes. What can we cross reduce?
4 and 70.
The 4 and the 70 are both even numbers. Since they're both even numbers, we can divide all even numbers by 2. So 4 divided by 2 is 2. 70 divided by 2 is... So 35 times 5 is... Go to your margin. 35 times 5. Now go back to your margin to divide so that I could change that back into a mixed number. So 6 goes into 17 twice. 9. 1 left over. So 6 goes into 175 29 times with 1 left over. Our denominator stays the same. My unit is inches, and then it's cubed. So the volume is 29 and 1/6 inches cubed. So remember, when trying to find the volume of a rectangular prism, you can do length times width times height. You can do length times width times height, but since we know length times width is the area of the base, we could also just do volume equal area of the base times the height.